Alright, so let's go over your homework. I had asked you to do on page 367, 16 to 22 even, and 30. So problem number 16. And really what I told you in class was I really just expect you at this point to be able to convert to sines and cosines. So the hardest area of this equation is clearly the left. And actually, I'll show you two ways to do this. The way that we talked about in class is we could write tangent as sine squared of theta over cosine squared of theta. Cosecant is 1 over the sine squared of theta. So on top, I could see that we need to get a common denominator. We'll need a cosine squared on the 1, so we multiply top and bottom by cosine squared. And we wind up getting, this will just be cosine squared of theta plus sine squared of theta over the single common denominator. And we're dividing by 1 over sine squared. Well, what is cosine squared plus sine squared? Using the Pythagorean identity, that's 1. And when you keep change flip, multiply by the reciprocal, you get sine squared of theta over cosine squared of theta, which is just tangent squared of theta, which is what we wanted. Another way to do this problem is using some other identities. So let's write the problem again. Now you might realize or recognize that this is just a Pythagorean identity. 1 plus tangent squared is secant squared of theta. Well, secant, let me see, over cosecant squared of theta. Secant squared is just 1 over cosine squared. We're dividing by cosecant, and you wind up with 1 over cosine squared times sine squared, which is exactly what we were doing over here. The answer is just tangent squared of theta. So there are multiple ways you could do these problems. I think most of you would find the first way a little bit easier, converting to sines and cosines. Let's do number 18. For problem number 18, it says secant of alpha over sine of alpha minus sine of alpha over cosine of alpha is equal to cotangent of alpha. So alpha is the same thing as theta or x or anything like that. So what I'm going to do first is, let's see what we have here. Let's convert this. Actually, you know, we have two fractions. It might be a good idea just to get a common denominator right away. I'm going to multiply both top and bottom by cosine of theta here to get sine cosine. And I'm going to multiply both top and bottom here by sine over sine to get sine cosine on the denominator. So we wind up getting cosine of alpha times the secant of alpha minus sine of alpha squared all over the common denominator, sine cosine. So now we have a common denominator. Let's go ahead and convert everything to sines and cosines. This would be cosine of alpha times 1 over the cosine well, cosine times 1 over cosine cancels, and we actually have a Pythagorean identity. This we've seen before. I know that sine squared plus cosine squared is 1, so what's 1 minus sine squared? It's cosine squared. So let's see what happens here. one of these cosines that you're squaring cancels with one of these cosines, and we just wind up with cosine over sine, which is what we wanted. This is just cotangent of theta. That one's a little bit longer, but I would expect everyone to be able to get to this step right here. Get a common denominator, convert. Common denominator might even be a little bit tricky, but hopefully everyone can convert to sines and cosines. Let's go to number 20. Number 20, it says tangent squared of theta minus sine squared of theta is equal to tangent of theta times sine squared of theta. Okay. So, both sides look pretty much the same. If we do convert to sines and cosines, the left side we need to get a common denominator. So I'm going to go ahead and start with the left side. Common denominator would be cosine, so I'd have to multiply top and bottom here by cosine squared of theta. And this turns into, remember we were working with the left side, this turns into sine squared of theta minus sine squared theta cosine squared theta all over cosine squared theta. Well, at this point, we could take out a sine squared on top. Remember, this is like having 2 minus 2x. We could factor out a 2 from that whole top. In this case, we could factor out a sine squared from the whole top. We just get 1 minus cosine squared of theta. This is tangent squared. So the only thing we have to get is sine squared, and guess where that's going to come from? If sine squared plus cosine squared is 1, 1 minus cosine squared is sine squared. So we wind up with sine squared theta times sine squared theta all over cosine squared theta. This piece is tangent squared, and we have sine squared. A couple more, number 22. Good Taylor Swift song. Sine of theta plus cosine of theta is equal to 1 plus tangent of theta over secant theta. Now the left side, there's not really anything we could do with that, so let's start with the right, and I'll convert to sines and cosines. Now on top we can get a common denominator. I'll multiply top and bottom by cosine. And we'll get on top cosine of theta plus sine of theta all over cosine of theta. And we're dividing by 1 over the cosine of theta. Well, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. These will cancel, and this is your answer, just sine of theta plus cosine. Doesn't matter what order you add in. It's called the commutative property of addition. And it looks like we have one more here, number 30. So for problem number 30, we get tangent of x over sine of x, and that's equal to root 2. We want to convert this just to a single trig function. Well, I think we did something like this in class. Tangent was sine of x over cosine of x. We're dividing by sine of x, which means we can multiply by the reciprocal. These cancel. 1 over cosine is just secant of x. So as far as what the answer would be, this is the same thing as just saying secant of x is equal to root 2. All right. Thank you so much. Have a nice day.